Morning to all. Am I audible? Can anyone message me? Am I audible? Is my voice clear? Am I audible? Can anyone message me in the chat box? Please mention whether I'm audible or not. No one is responding. Am I audible? Is my voice? Are you able to hear my voice? Audible? Okay, then I will start the session. Okay, today I will discuss Tellegen'S theorem. So Tellegen'S theorem is valid for lumped networks. I'll take the laser. Okay, it is valid for lumped networks, and these lumped networks may be linear or non-linear. Okay, and these may be passive or active, or they may be time variant or time invariant. Okay, so this theorem, Tellegen'S theorem, states that in an arbitrary lumped network, the algebraic sum of powers in all branches at any instant is equal to 0. Okay, so what does it state? In an arbitrary lumped network, the algebraic sum of the powers in all branches at any instant is 0. So, in this theorem, what we are going to do is, in order to verify this theorem, we have to determine the branch currents and voltages, each and every branch current and voltage, okay, by applying Kirchhoff's voltage law or current. Okay. So all branch currents and voltages in this network, they must satisfy Kirchhoff's laws, that is current law and voltage law. So we will implement Kirchhoff's voltage law or current law to determine the branch currents or voltages. Okay. So there is another statement here. Okay. So let us see the other statement, one more statement. In a given network, the algebraic sum of all the powers delivered by all the sources is equal to the algebraic sum of all the powers absorbed by all the elements. So, and compared to the previous statement, this statement is much more easier to understand. Why? Because we know in a given network there will be sources. Where is the sources? These are. There will be sources. The sources are the one who deliver the power. and this delivered power must be absorbed by the passive elements that are available in the network. So sources are the active elements, and passive elements are the one which absorbs the power. Okay, so the power delivered must be equal to the power absorbed according to Tellegen'S theorem. Okay, so let us take a numerical problem and let us verify this theorem. So using Tellegen'S theorem, find the voltage across 6 ampere current source for the given circuit. So where is 6 ampere current source is there? Voltage across 6 ampere current source is asked. This is our 6 ampere current source. So they have asked us to find the voltage across 6 ampere current source. So you can see it's a 2-loop circuit. So in this 2-loop circuit, there is a voltage source, there is a current source, and only two passive elements are there. One is 6 ohms resistor, another one is 2 ohms resistor. Okay. Now, so let us assume the current that is coming out of this source, okay, is some I1. Some notation I have given. So what is I1 current that is coming out of this current source? That is I1 equal to 6 amperes. Okay, I1 is equal to 6 amperes. Okay, so just I have given some notation to this current source, that is I1 is coming out of this source. Okay, now I have written two-term solution. Now here let us consider branches here. Just let us give the naming to each branch. So how many branches are there? This is one branch, this is one branch, this is another branch. Total 3 branches. So I have given some naming to these branches. Branch 1, branch 2 and branch 3. What is my branch 3? I will take eraser. My branch 3 is, this is my branch 3, which is consisting of R2 resistance and this voltage source. Branch 1 is only current source is there. This is my branch 1. In branch 2 only resistor of 6 ohms is there. Okay, I am erasing all this. So total 3 branches are there. See, across 6 ohms I have given some notation to 6 ohms resistor R1. For 2 ohms resistor I have given some notation R2. Okay, so one current source and one voltage source is available here. Okay, so total how many branches are there? 3 branches are there. So I have considered loop currents or mesh currents, I can say. So let us consider this is our mesh 1. Mesh 1. This is mesh 2. My cursor won't listen to me. I will erase all inks and I will once again I will write mesh. Again it's not listening to me. One and mesh 2. Okay, 2 meshes are there. I have considered 2 mesh currents, I1 and I2. What is I1? Just now I have told you I1 is nothing but if there is a current source in a loop, then the loop current will be equal to the current source value, that is 6 amperes. Now I have to determine I2 value. Okay, I have I1, I have to determine I2. So we will apply KVL in loop 2 I'll just copy that image in this slide so that you'll be able to understand how to write this equation if you still don't know how to write KVL equation. So this is it. So you see, you have considered current in clockwise direction, and okay, current direction is clockwise, and the positive terminal of 12 volts is upward. So definitely the current that is coming out of this 12 volts voltage source will be upward. So both are opposite. That's why I have written here minus 12. Okay. So algebraic sum of source voltages in this mesh 2 is minus 12. So minus 12 is equal to, is my cursor, yeah, minus 12 is equal to 2 ohms into I2, 2 into I2. Voltage drop across R2 is 2 into I2. Now voltage drop across 6 ohms. What is voltage drop across 6 ohms? Let us see what is the voltage drop across 6 ohms. See here, 6 ohms is in between mesh 1 and mesh 2. Okay, it is in between mesh 1 and mesh 2. So I1 current flows downward, I2 current flows up. Isn't it? I2 current, I will just join this. So what is the current direction? This is the current direction. I1 current direction is here, this side it is upward, this side it is downward. So difference of I1 and I2 will flow. Both are in opposite direction, isn't it? This is upward and this is downward. So both are opposite direction. Therefore, difference of I1 and I2 currents will flow through 6 ohms. So 6 into I2 minus I1. Why? Because we are writing the equation for mesh 2, therefore I2 minus I1. Okay, so I hope you have understood what I was trying to explain. So we have written KVL equation. Now simplify this. Okay, you just expand this 6 into I2 minus 6 into I1 you will get, and you see 2 I2 terms are there, 2I2 and 6I2, you will get 8I2. So minus 12 equal to 8I2 minus 6I1. Okay. So we already know the I1 value, isn't it? We already know the I1 value. What is the I1 value? I1 equal to 6 amperes. So substitute that in this and simplify it, you will get I2 value. So 12 minus 12 equal to 8 into I2 minus 6 into I1 is 6 amperes, so 6. Okay. So 6 into 6, you will get 36. So minus 12 equal to 8I2 minus 36. And you can send 8I2 on one side and you can write all the numerical values on the other side. So what I have done is I have sent this minus 36 to the other side. So 8I2 is equal to 36 minus 12. You will get 24. 8I2 is equal to 24. I2 equal to 3 amperes. So I1 is 6 amperes. I2 is 3 amperes. I hope you are able to follow. So you must have the basic knowledge of KVL and KCL to solve the numerical problems. Now, what is the current flowing through? Current flowing through the branch 2. In branch 2, what is there? I will just copy the image here so that you will be able to understand. So now in branch 2, what is there? 6 ohms resistor is there. In branch 2, 6 ohms resistor is there. So what is the current flowing through 6 ohms resistor? I2 minus I1 is the current flowing through 6 ohms resistor. So I2 minus I1 or I1 minus I2, you wish anything, you can write, you can consider any either I1 minus I2 or I2 minus I1, both are same. Okay, so I have considered I2 minus I1. So if I consider current through 6 ohms is I2 minus I1, I2 value is 6 and I1 is 3. So 6 minus 3, I am getting 3 amperes. So current through 6 ohms resistor is 3 amperes. Okay, so now let us calculate the power in each branch. Okay, now in branch 1, let us assume branch 1. What is there in branch 1? Only current source is there. In branch 1 only current source is there. So if I want to calculate the power in branch 1, I have given the notation in branch 1 power as P1. P1 is the power in branch 1. Okay, power in branch 1 I have considered, or power that is flowing in this branch 1 is P1. So P1 is equal to, I have assumed V into I1. Okay, I know I1 value. What is I1? 6 amperes. What about V? I don't know. So I have left it as it is. 6 into V. Okay, so I don't know the voltage in branch 1. Simply, I just know the current. So I have written 6 into V. Okay, now let us go to branch 2. In branch 2, what is there in branch 2? 6 ohms resistor is there. Nothing else is there. So let us assume current through branch 2 is P2. Okay. So current through branch 2 is P2 and sorry. Power through branch 2 is P2, not current, sorry. Power in branch 2 is P2. So what is the power formula? Okay, V into I or I square R. Okay, I square R. So R is R1 and I square is what? Current through 6 ohms resistor. I 6 ohms I have written, that we have already calculated 3 amperes. So R1 value is 6 ohms. R1 value is 6 ohms. 6 into 3 square. Okay. 6 into 3 square. 3 square means you will get 9. 6 into 9 you will get 54 watts. So power through branch 2 we have calculated. Okay. Power through branch 1 we couldn't calculate. Why? Because we only know the current, we don't know the voltage in that particular branch. That's why I have simply written 6 into V. So power in branch 2 we have calculated. What is it? I square R. I have considered the formula as I square R. So I square value is how much? I value is 3 amperes. So 3 square into R value is 6. So 6 into 9 you will get 54 watts. Now let us go to branch 3. Till now in branch 1 current source was there. In branch 2 only resistor was there. In branch 3 two elements are there. Okay. In branch 3, two elements are there. One element is R2, another element is voltage source. Okay, one element is R2, another element is voltage source. So we have to calculate two powers in branch 3. Okay, in branch 3, we have to calculate two powers. So one is one power is power across the resistive element. So let us give the notation for the power across resistive element, that is R2 is P3. Okay, power through resistor R2 is P3. So what is the power formula? Yeah, wish you can write V into I or simply I square R. Why I am writing I square R? Why? Because I have already calculated the current values by using Kirchhoff's voltage law. Okay, that's why. What is the current through R2 is I2. So I2 square. Okay. So I simply have written I 2 ohms square into R2. So R2 value is 2 ohms into current through I2. What is I2? I2 current we have just now calculated. What is current? I2 current? I2 current is 3 amperes. Okay, I2 current is 3 amperes. So 3 square you will get 9. So 2 into 9 it is 8 watts. Okay. So I1 value is 6 amperes. I2 value is 3 amperes. I2 value is 3 amperes. Now we have calculated the power through resistor R2. Now let us calculate the power through the voltage source. What is it? Voltage source. This one. Voltage source, I am assuming this M notation V, and current through a voltage source is how much? I2. So current voltage minus 12 into 3. No, even if you won't write minus 12, it doesn't matter. You can write simply 12 also. Okay, you can consider only magnitude. So earlier in the while writing KVL, I have written minus 12, and the assumed current direction is opposite to the current that is coming out of this source. That's why I am writing minus 12. So minus 12 into 3, you will get minus 36. Instead of minus, you can simply write 36. Okay. So no need to consider. Minus is not necessary. Minus represents that assumed current direction is opposite to the actual current direction. That's it. Nothing else. So how many elements do we have here? Let us check. How many elements do we have? This is one. What is that one? Current source. Okay. Where is my cursor? Did I take cursor here? This is one. This is two. This is three. And this is 4. Total 4 elements are there, and we have got some values for these 4 powers. So 4 elements are there, 4 powers we have calculated. Of course, P1 in P1 we didn't get any value. We have written 6V. That's it. We don't know the V value. Okay. So, but for the remaining elements, we were able to calculate the power. Okay. So now here, which powers are the powers that are delivered by the sources? P1 and P4, isn't it? You just check here. Where are our sources? I will erase all the inks. Where are our sources? Current source, voltage source. Means P1 and P4. P1 and P4 are the powers delivered. Okay, P1 and P4 are the powers delivered. What are all the elements which are absorbing the power? This resistor and this resistor, R1 and R2. R1 and R2 are absorbing the power. Means power is absorbed. Absorbed powers are P2 and P3. Okay, P1, P2 are the absorbed powers, whereas P1 and P4 are the delivered powers. That's what I have written in the next slide. P2, P3, they are the absorbed powers. Powers absorbed by the branches. So power delivered by the branches is P1 and P4. Okay. So power delivered according to Tellegen'S theorem, power delivered must be equal to the power absorbed. Algebraic sum of power delivered must be equal to the algebraic sum of powers absorbed. What is the power delivered? P1 plus P4. What is the power absorbed? P2 plus P3. So P1 plus P4 is how much? P1 is 6V. 6 into V minus 36. P4 is 36. Okay. And P2 is 54 and P3 is 18. Okay. So I don't know why I did not consider them as subscripts. These are the subscripts. Okay, now simply simplify it. You will get the voltage across 6 amperes. 6 into V minus 36 equal to 4 plus 18, and 6 into V equal to send 36 to the other side. 54 plus 18 plus 36, you will get V equal to 18 volts. So the voltage across the 6 amperes current source is 18 volts. So this is a simple numerical problem. I hope you were able to understand. Okay. So do you want me to repeat, or do you want me to continue this numerical problem? Are you able to understand? You can text in the chat box. Do you want me to continue? If you want me to continue, just type C. If you want me to repeat, type R. Are you able to follow? Shall I go to the next problem, or do you have any doubts in the first numerical problem? No response? Is there anyone in this session or no? Okay, I didn't receive any response. No one is responding. No one is responding. I don't know why. Okay, then I'll continue. So I have considered one more numerical problem. In this numerical problem, I am going to verify Tellegen'S theorem. So see here, in this numerical problem, you can see two sources. Voltage source V1 of 30 volts, voltage source V2 of 30 volts. Both the voltage sources are of same voltage. Okay, same voltage. And you can see here I have considered two T networks. I'll take pen. I have considered two T networks. They are connected in cascade. See here, same networks. You just see 47 ohms, 47 ohms, 510 ohms, 510 ohms, 2000 ohms, 2000 ohms. So here I have considered two T networks. I will erase all links and I will just divide into two parts. Just carefully observe on the left side and right side of this red line which I have drawn. Okay, you can see both the T networks are similar. So I have joined two T networks together. So in this numerical problem, we have to verify Tellegen'S theorem. Okay, so let us verify the Tellegen'S theorem. So here if you observe, there are three meshes. Mesh 1, mesh 2 and mesh 3. Total three meshes are there. So I have applied mesh currents here. See here, I have considered I1 mesh current in clockwise direction. I2 mesh current, again it is also in clockwise direction. I3 mesh current, I have considered in anti-clockwise direction, or which you can assume either in clockwise or anti-clockwise. It is your own interest. It's not going to affect your parameters which you are going to determine here. So I have considered I1 clockwise, I2 clockwise, whereas I have considered I3 anti-clockwise. Okay, so it is not mandatory to consider means what to say, all the loop currents or mesh currents in clockwise, or all the mesh or loop currents in anti-clockwise. So the reason that I have considered this I3 in anti-clockwise, the reason behind that is there is a source in this mesh. The current will come out of this voltage positive terminal in this direction, which will flow in anti-clockwise direction. That's why I have considered I3 in anti-clockwise. That is the reason. There is no need to follow the source. You can assume I3 current also in clockwise direction. Okay. So first of all, to verify Tellegen'S theorem for the given circuit, what I have done is I have assumed all the currents in not all the currents. I have assumed I1 and I2 in clockwise, I3 in anti-clockwise direction. Now I will apply Kirchhoff's voltage law to determine the mesh currents. Nothing else. Okay. So I will just copy this image in the next slide. So see here, applying KVL in mesh 1. Okay, I apply KVL in mesh 1. So there is a voltage source of 30 volts. So 30 is equal to voltage drop across 47 ohms. What is it? 47 into I1. Okay, next voltage drop across 2000 ohms. So you just observe, this is downward, this is upward. So both are opposite. That means differential current will flow through 2000. So I1 minus I2. 2000 into I1 minus I2. Okay. So 47 I1 plus 2000 into I1 minus I2. You just expand this term, you will get this. Okay. So after that you can see you have two I1 terms. So just solve it, you will get 2047 I1 minus 2000 I2 equal to 30. Consider it as equation 2. Consider the first equation as equation 9. Okay. One second, you just go through this. I will drink water. So I hope you were able to understand. So now once again I will copy this image in the next slide. Now if you observe here, applying KVL in mesh 2. Okay, I will take the laser. Applying KVL in mesh 2. So in mesh 2, if you observe, there are no sources. All passive elements are there. Okay. So all passive elements are there. So I will start with 510 ohms. So 510 ohms. What is the voltage across 510 ohms? I2 into 510. So this is it. 510 into I2 I have written plus 47 into how much? I2. So 47 into I2 plus this 2000. Okay. This 2000 and this 2000. First of all, here I have written 2000 into I2 minus 7. So I will discuss about this. 2000 into I2. This is upward. This is downward. So 2000 into I2 minus I1 plus this 2000 is there. You just observe this is downward. This is also downward. Both are in same direction, isn't it? I3 current and I2 current. This is downward. This is also downward. Both are in same direction. So 2000 into I2 plus I3. 2000 into I2 plus I3. Okay, just expand this. Consider this as equation 3 and expand this. So 510 I2 plus 47 I2 plus 2000 I2 minus 2000 I1 plus 2000 I2 plus 2000 I3 is equal to 0 you will get. And you can see many I2 terms are there. 510 I2 plus 47 I2, 2000 I2 and 2000 I2. So add all the I2 terms. You will get 4557 I2. This I is looking like 1, isn't it? These eyes are looking like 1. I will just change the font. I will write Time New Roman. Now it is okay. these eyes are looking like 1, that's why I have changed the font. Now see, yeah, 4557 I2 plus 2000 I3 minus 2000 I1 equal to 0 you will get. You can write in order I1, I2, I3 order. So I have changed the order of the above equation. So this is minus 2000 I1 plus 4557 I2 plus 2000 I3 equal to 0. Okay, so consider it as equation number 4. Okay, now let us go to the next slide and let us apply mesh 2 equation number let us apply apply KVL to mesh 3. So let us apply KVL to mesh 3. So where is our mesh 3? This is our mesh 3. This is our mesh 3. In this mesh 3 you can see there is a voltage source, resistors. I have given some notations to these resistors. This is R6 and this is R5. So 510 ohms resistor and 2000 ohms resistor are there in this mesh 3. So now let us apply KVL in this. 30 is equal to, so algebraic sum of voltage sources. 30 is equal to 510 into I3, 510 into I3 plus 2000 into I3, this I3 current and I2 current both on same dash. So 2000 into I2 plus I3. So consider it as equation number 5 and just expand it. This 2000 I2 plus I3 you can write it as 2000 I2 plus 2000 I3. So 510 I3 plus 2000 I2 plus 2000 I3 equal to 30. And 2 I3 terms are there and you just add those two terms. So you will get 2000 I2 plus 2510 I3 equal to 30. Consider it as equation number 6. So now we have written all mesh equations, isn't it? We have written all mesh equations. Now consider equation 2, 4 and 6. Okay, where is equation 2? This is equation 2. Okay, consider equation 2. Next, equation 4. Okay, consider this equation 4 and equation 6. Okay, I just substitute these equations in your calculators if you have a scientific calculator. So substitute these equations in your calculator and directly will get the answers from the calculator. No need to manually calculate I1, I2 and I3 values. So I have got this I1 as 0.0198 amperes, I2 as 0.00535 amperes and I3 as 0.00768 amperes. So if you want, you can convert them into milliamperes. I1 is 19.8 milliamperes. If you want, you can convert. Otherwise, leave it as it is. No need to convert. I2 is 5.35. 35 milliamperes. Okay, similarly I3 is 7.68 milliamperes. Okay, you can convert into milliamperes if you want, otherwise you can leave it as it is. That's it. Now we have our mesh currents. We can write the current across each element. We can write the current across each element now. So how to write it, I will tell you. So see, current flowing through each resistor, IR1. So it's better to copy the image here, circuit diagram here. circuit. I'll just copy it. Now, what is IR1? Current flowing through R1. Okay, current flowing through R1. Okay, let us now assume it as IR1. So IR1 is nothing but I1 current, isn't it? Current flowing through R1 is I1. So what is I1? I1 we have already calculated 0.0198 amperes. Okay, now current flowing through R2. Current flowing through R2. So let us assume that current as IR2. Current flowing through R2 as IR2. So what is IR2? Current flowing through R2 is difference of I1 and I2. Difference of I1 and I2. So here I have written I1 minus I2. So I1 is 0.0198 and I2 is 0.00535. So just subtract these two terms, you will get 0.01445 amperes. Okay, now I am erasing all links. Now next term is R3. Okay, next is R3. So what is the current through R3? R3 current is I2, that's it. So current through R3, let us give some notation. IR3 is the current through R3. What is that? Yeah, here I have combined R3 and R4 here. It's okay. So current through R3 is I2. What is that current? 0.00535 amperes. I have two times I have written amperes here. Okay, I will erase this. Okay, now what is the current through this R4? Current through R4 is also I2. That's why here I have equated IR3 is equal to IR4 equal to I2 equal to 0.00535. Okay, so current through R4 we have calculated. No, we have not calculated, already do by applying KVL in mesh 2 we have calculated. Now next term, current through R5, that is 2000 ohms. Okay, so current through R5, IR5. What is the current through R5? I2 plus I3. So I2 plus I3 both are in same direction, therefore I2 plus I3. So I add both the currents. So I2 is 0.00535 and I3 is 0.00768. So just add those two, you will get 0.01303 amperes. Okay, so you need a calculator because you have to do many calculations. If you want to do manually, you can do it, but it will consume time. So not to save time, it's better to have a scientific calculator. Otherwise, your time will be wasted. Next, what is left over? One more element, that is R6. Okay, so what is the current through R6? Let us assume that current through R6 is IR6. What is the current flowing through R6? Nothing but I3 current. So I3 is how much? 0.00768 amperes. So we initially determined the mesh currents. After determining mesh currents, now we have determined current flowing through each and every resistor that is there in the given circuit. Okay, all passive elements, isn't it? What are all the passive elements that are there? All resistors. How many resistors approximately here? Not approximately, exactly there are 6 resistors. Okay, so current flowing through, where is my cursor? Yeah, current flowing through each resistor we have calculated. Okay, now let us proceed. Now let us determine the voltage across each resistor. Voltage across each resistor. So voltage across R1 is IR1 into R1 value is 47. To be more specific and to be more clear, let us copy that image of your circuit in this slide also. Okay. copied it here. So what is R1? R1 resistance value is 47 ohms. Current through R1, just now we have calculated IR1. So voltage across R1 is VR1 equal to IR1 into 47. Okay, so IR1 is 0.0198 into 47. If just multiply, you will get 0.9306 volts. Okay, 0.9306 volts. Similarly, voltage across R2. This is our R2. What is it? 2000 ohms. So voltage across R2 is IR2 into 2000. IR2 just now we have calculated, that was 0.01445 into R2 value is cursor. Yeah, R2 value is 2000. Just multiply these two, you will get 28.9 volts. Similarly, voltage across R3. Where is R3? This is R3. Okay, R3 value is 510 ohms. So voltage across R3 is IR3 into 510. IR3 just now we have calculated, that is 0.00535 into R3 value is 510, multiplied you will get 2.72 volts. Similarly, voltage across R4. This is R4. Voltage across R4 is IR4 into 47. So IR4 value is 0.00535 into R4 value is 47. Where is my cursor? Yeah, R4 value is 47. Just multiply those two, you will get 0.25 volts. Similarly, next element, what is next? R5. So voltage across R5. Current through R5 into resistance value. Current through R5, just now we have calculated, that is 0.01303 and R5 value is 2000. Just multiply those two, you will get 26.06 volts. Now voltage across R6. Where is R6? This is R6. So voltage across R6 is current through R6 into its resistance value. R6 value was 0.00768 into resistance value is 510. Just multiply, you will get 3.16 volts. So now we have determined now we have determined the voltages across each and every resistive element. So we have determined the currents flowing through each and every resistor, current flowing through each resistor. We have determined voltage across each resistor. Now we can determine the power. Okay, power absorbed by each and every resistor. So I have calculated later on power absorbed by each and every resistor. So okay, let us calculate the power absorbed by each and every resistor. So power absorbed by resistor 1, R1. Power absorbed by R1 is how much? Let us give some notation. PR1, that is equal to VR1 into IR1. Actually, you can even write IR1 square into R1, but I calculated the voltage and multiplied it with current. So VR1 is 0.9306 and IR1 is 0.0198. Multiply both, you will get 0.0184. Next, power absorbed by R2. Give some notation. PR2, power absorbed is VR2 into IR2. So VR2 is 28.9, IR2 is 0.01445. Multiply it, you will get 0.418 watts. Okay. Similarly, power absorbed by R3. Give some notation. PR3 and that is equal to what? VR3 into IR3. So we have already calculated those values. So VR3 is 2.72, IR3 is 0.00535. And you just multiply these two, you will get 0.0145 watts. Similarly, calculate the power absorbed by R4. So give some notation to that. PR4. So PR4 is VR4 into IR4. VR4 is 0.25 and IR4 is 0.00535. Just multiply these two, you will get 0.0013 watts. Okay, so I'm explaining you in the simplest possible way that you can understand. I hope if you are listening carefully, you will be able to follow. So PR4 we have got, still two more terms are left over. If you remember, there were total 6 resistors. So power absorbed by R5. Let us give some notation. PR5 is the power absorbed by R5. So VR5 into IR5. VR5 is 26.06 and IR5 is 0.01303 and just multiply, you'll get 0.34 watts. Next, power absorbed by resistor R6. So notation PR6 and PR6 is equal to VR6 into IR6 and VR6 value was 3.16 and IR6 was 0.00768. So just multiply, you'll get 0.024 watts. Okay. Now we have calculated power absorbed by all the resistors. So what is the total power absorbed? PR1 plus PR2 plus PR3, PR4, PR5 and PR6. Just add all the powers absorbed by all the resistors. If you add, you will get 0.816, which is approximately 0.82. Okay. So this is the total power absorbed by all the resistors. If you just take a minute, go through this slide. Don't consider this. Why? Because before calculating the power absorbed by resistors, I have calculated the power delivered by the sources. So this numbering has changed. Just take a minute, go through this slide. So I hope you are able to follow. Now let us calculate the power delivered by the sources. How many sources are there? I will just copy the image here. So how many sources were there? Two sources. Two voltage sources were there. V1, V2. So what is the power delivered by V1? Power delivered by V1. PV1 is equal to V1 into I1. So what is V1 value? 30. I1 value we have calculated 0.0198. Okay. So yeah. V1, I1. V1 value is 30. I1 value is 0.0198. Just multiply, you'll get 0.59 volts. Next, power delivered by V2. Power delivered by this source V2. So let us give some notation PV2. That is equal to V2 into I2. What is V2 value? 30. I2 value is 0.00768. Multiply, you'll get 0.23 watts. What is the total power delivered here? PV1 plus PV2. What is PV1? 0.594. PV2 is 0.2304 actually. I didn't write here. I have written only 0.23. If you add these two, you'll get approximately 0.82 watts. Okay. So what is the power delivered? Power delivered is total power delivered by both the sources. So both the sources are delivering 0.82 watts power. And what is the total power absorbed? Total power absorbed. How much? 0.82 watts. I didn't write watts here. Okay, I'll add watts. Okay, so total power absorbed is 0.82 watts. Total power delivered 0.82 watts. So total power delivered is equal to total power absorbed. Okay. See here I have even written the notations comparing the above two equations, total power delivered and total power absorbed. Total power delivered is PV1 plus PV2. Total power absorbed is PR1 plus PR2, PR3 plus PR4 plus 5 plus 6. Okay. So total power delivered is 0.82 and total power absorbed is 0.8162, which is approximately 0.82. So both are equal. So hence Tellegen'S theorem is verified. Okay, total power delivered and total power absorbed is same. Therefore, Tellegen'S theorem is verified for these two circuits. Okay, these two circuits means, as I have already told at the beginning, that these two here, this is a T network, this is a T network. So both the T networks of same topology are connected here in the given circuit. So Tellegen'S theorem is verified. That's it. If you want me to repeat, you can mention repeat, or okay, if you want me to repeat, you can mention repeat. If you have any doubts, you can mention in the chat box. Otherwise, I will create the Google form and you can fill the Google form. Next session I will take today afternoon after maybe at 3 p.m. 3 p.m. I will take the afternoon session at 3 p.m. So join the session, next session at 3 p.m. today. I will just now fill the Google form and you can leave the session. Someone wants me to repeat. So do you want me to repeat the whole numerical problem? Or briefly you want me to? Some people have mentioned, okay, one person has mentioned someone wants me to repeat. So I will not go into details, but briefly I will just as quickly as possible I will conclude this numerical problem. Okay, so this is our given numerical problem. This is the given numerical problem which has two sources. Just wait, others. Someone has mentioned repeat. For that particular person, I am going to repeat and I will conclude as quickly as possible. So two sources are there. Okay. So two sources are delivering the power. And how many passive elements are there total? 6 passive elements. 6 resistors are there. They absorb the power. So according to Tellegen'S theorem, power delivered must be equal to power absorbed. So we have to calculate the power delivered and power absorbed by each and every element. For that, what I have done is I have considered the given circuit. I have considered the mesh currents in each mesh. 3 meshes are there, so I have considered 3 mesh currents, and I have assumed I1 and I2 current in clockwise, I3 in anti-clockwise. Okay, so later on I have written the mesh equations. So I have applied KVL in mesh 1 and I wrote the mesh equation. I have simplified, I have got equation number 2. Okay, so, once again I have applied KVL in mesh 2. So you must have the basic knowledge of KVL and KCL. I have applied KVL in mesh 2 and I have written the mesh equation 3. I have simplified, I have got the equation number 4. Okay, once again I have applied KVL in mesh 3. So I have got this expression number 5. And I have simplified, I have got equation number 6. After that, I have substituted equation number 2, 4 and 6 in a scientific calculator. Okay, and in order to get the unknown terms. So you must have a scientific calculator to determine the unknown terms. So I have got some value for I1, I2 and I3. After determining I1, I2, I3, what I have done is I have determined current across each and every resistor, current through each and every resistor. So current through R1 was I1. So and current through R2 was I1 minus I2. Current through R3 and R4 was same, that is I2. Current through R5 was I1 plus I3, and current through R6 is I3. Okay. And later I have determined the voltage across each and every resistor. So voltage across resistor R1 was IR1 into that resistance value. Voltage across R2 was IR2 into the resistance value. Voltage across R3 was IR3 into that resistance value. Voltage across R4 was IR4 into that resistance value. Voltage across R5, IR5 into that resistance. Voltage across R6 is IR6 into that resistance value. So I have calculated the voltage across each and every resistor. Earlier I calculated current flowing through each and every resistor. I have multiplied each voltage and current to determine the power. So voltage across, sorry, not this one. So power absorbed by resistor R1 I have calculated. What is it? Power across R1 is VR1 into IR1. Similarly, power across R2 is VR2 into IR2. Power across R3 is VR3 into IR3. Power across R4. Power across means power absorbed. Power absorbed by R4 is VR4 into R4, IR4. Similarly, power absorbed by R5. That is it. R5 is VR5 into IR5. Power absorbed by R6 is VR6 into IR6. So I am just briefing it because someone asked me to repeat for that reason. So now just add all the powers. If you add, you will get some 0.816, which is approximately 0.82 watts. This is the power absorbed by all the elements, total power absorbed. Now let us calculate the power delivered. Power delivered by two sources are there, source 1 and source 2. So what is the power delivered by V1? Power delivered by V1 is V1 into I1. So V1 value is 30, I1 we have already calculated 0.0198. Just calculate, you will get some value. Power delivered by V2, okay. PV2 is V2 into I2. V2 is 30 and I2 is 0.00768. You just multiply, you will get this value and add these two powers, PV1 and PV2. Okay. You will get 0.82 watts. Okay. Now compare both the powers. Power, total power delivered and total power absorbed. If you compare, you will find that both the powers are same. Hence Tellegen'S theorem is verified. Okay. So I just quickly just recalled this numerical problem. If you whoever wanted me to repeat, if still you are unable to understand, later on you go through this video, because step by step I have explained very slowly earlier. Now if I repeat the same in the slow pattern, so others who are watching this session, they will get bored. Okay, so they will lose interest. So that's why I just quickly briefed it. You can go through this video later on. You will definitely understand. Okay, so I will go to the Google form, and I will create a Google form. All of you fill the Google form. fill the Google form. If you complete filling the Google form, you can mention in the chat box, and you can leave the session. You can rejoin the session at 3 p.m. Okay, if you have completed, you can leave the session and you can rejoin at 3 p.m. I hope everyone has completed filling the Google form. I'm going to conclude this session.